On Thanksgiving, NASA launched its newest mission, called the Europa Clipper.
3, 2, 1, ignition. And liftoff. Liftoff of Falcon Heavy with Europa Clipper.
And on the outside of this 5.8-ton spacecraft is a poem titled In Praise of a Mystery, written by U.S. Poet Laureate Ada Limon. It's read here by Ivan Semeniuk, the Globe's science reporter.
Arching under the night sky, inky with black expansiveness, we point to the planets we know. We pin quick wishes on stars. From Earth, we read the sky as if it is an unerring book of the universe, expert and evident. Still, there are mysteries below our sky. The whale song, the songbird singing its call in the bough of a wind-shaken tree. We are creatures of constant awe, curious at beauty, at leaf and blossom, at grief and pleasure, sun and shadow. And it is not darkness that unites us, not the cold distance of space, but the offering of water, each drop of rain, each rivulet, each pulse, each vein. O second moon, we too are made of water, of vast and beckoning seas. We too are made of wonders, of great and ordinary loves, of small invisible worlds, of a need to call out through the dark.
I find that poem actually
That's
quite
lovely.
beautiful. Yeah.
And I agree that we're made of water. Follow the water has always been the mantra for astrobiology, for the NASA planetary program as well. It looks as though underneath that icy crust of this moon of Jupiter, there is a liquid water ocean, and that's been extremely intriguing.
Today on the show, we're going to travel to that watery moon, Europa, with Ivan. He'll explain the details of the Europa Clipper mission and what it might reveal to us about life in the universe. And then, Ivan will get us caught up on a few other cosmic events that have recently happened that you may have missed. I'm Menaka Raman-Wilms, and this is The Decibel from the Globe and Mail, here on Earth. So Ivan, just to start, can you take us to Europa, Jupiter's moon? What is it like there?
It's fascinating. Europa is the smoothest object in the solar system, which is interesting. It has very little relief on its surface. No mountain ranges, no canyons, nothing like that. Although it's crisscrossed with these lines that make it look like a skating rink that has partially melted and then refrozen.
So like a big round spherical skating rink, essentially.
Right.
Huh.
There's an absence of craters, which is a top sign of a young surface. The surface is estimated to be maybe tens of millions of years old, which is peanuts. Most of the solar system, like our moon, for example, which is similar in size to Europa, has a surface that's billions of years old. So Europa is recent. It's obviously been resurfaced by various processes, which probably have to do with the fact that it's a moon that's made of rock, and maybe even have a metallic core. So it's like a very small version of Earth in a sense, but it's surrounded by a kind of a watery crust, maybe 100 kilometers thick, some of which is liquid, some of which is ice. And the real question is, how thick is the ice? How large is that watery ocean? And how warm is it? What might conditions be like in there?
Yeah, because this is kind of a question I have when you're talking about the warmth and the fact that it could be water. Why isn't it ice? It's so far out in the solar system. It's so far from the sun. Why isn't it just frozen?
So you're absolutely right. If you had a ball of a sphere of water at that location, it would freeze solid. So what could give Europa an ocean under the ice? It's one of 4 large moons that orbit around Jupiter. Jupiter has dozens of moons, but there are 4 that are especially large, similar or larger in size to our own moon. And as they orbit, they have this sort of peculiar resonance to their orbits. The inner one is Io. The next one out is Europa. Io orbits twice as fast. So in other words, every 2 times it goes around Jupiter, Europa goes around once. And then the next one out is Ganymede. It has a similar resonance where every time Europa goes around twice, Ganymede goes around once, and then Callisto is a little bit further out. So what happens is Europa is repeatedly having these regular encounters where it experiences the gravitational pull of its neighboring moons. And of course, they're all locked in Jupiter's gravitational pull as they race around. So as these other moons approach and move away from Europa, Europa flexes a little bit. It kind of squeezes and stretches and squeezes and stretches. And imagine this tidal pull on Europa is causing friction within the moon, and that's creating enough energy to keep part of the icy crust liquid. And the question is, maybe there are hotspots, maybe there are deep sea vents. It's a little bit of an open question just how warm it could be. But if there's enough energy from that heat, it could drive chemical reactions. We know there are organic molecules present in that part of the solar system. You've got the water. So these are the kinds of ingredients you would need for some kind of deep sea habitat where you could have maybe microbes thriving on chemical energy as they do in the deep sea vents around Earth without the need for sunlight.
Wow. Okay, this is so interesting. So this brings us then to kind of the mission of this new NASA spacecraft, the Europa Clipper. What exactly is this spacecraft trying to do, Ivan?
This particular mission, called Europa Clipper, is meant to characterize Europa better than we've ever done before and try to answer the question of whether it could be habitable. It won't land on Europa. It can't go through the ice, but it can apply a battery of remote sensing technologies to try to understand what's going on under the ice. It has ice-penetrating radar. It has other methods of sensing the ocean under the ice, magnetometers and so on, because electric currents will flow through the ocean. And also, it can look at the surface in great detail and analyze the chemical composition of the surface. And that's important because it seems there is evidence from a previous mission, from the Galileo mission, that there may be venting of water vapor out onto the surface. So you imagine those cracks on Europa, maybe occasionally some cracks open up, some holes open up, and some water vapor is able to escape out to the surface. So if Europa is doing this, whatever is in that ocean, in addition to the water, the salts, the chemicals, the molecules, maybe even something more interesting, could find itself splattered out onto the surface. And so a spacecraft observing remotely could at least do a chemical analysis of this.
So it sounds like we know that there's water there. We're pretty confident about that. So is the purpose of this mission then to actually look for life on Europa?
So Europa Clipper doesn't have the resources to actually discover life one way or another, but it could essentially decide whether or not this is a likely place for life to exist. And if it makes some interesting enough discoveries, that then might lead to follow-up missions. The tricky part about this sort of mission is that Jupiter is an extremely hostile place to be. Jupiter is a massive planet, giant ball of liquid hydrogen and helium. It has a metallic section in the middle where the hydrogen is so compressed, it's in a kind of metallic form that generates this powerful magnetic field and intense radiation all around it. And Europa swims inside that intense radiation environment around Jupiter. So the spacecraft, if it was just sitting on Europa, would probably be fried and quickly would be lost. So the way this mission is set up, Europa Clipper will sort of dive in for quick glimpses and then pull away to safety, dive in, pull away with these elongated orbits that come in close then far away. And the nominal mission is it's going to do this 49 times and also take a look at some of Jupiter's other moons, but Europa is the main focus.
Okay. And when are we actually going to get, I guess, some of the answers to the questions that we have here? Like, how long is this process going to take? The Clipper was just launched.
Well, be prepared to wait. Don't start the popcorn just yet. It's a long trip to get out to Jupiter, and this is the kind of trip where spacecraft will use gravitational assists by closely passing other planets on the way. So depending on exactly when this happens, it'll be either late February, early March of next year. It will pass close to Mars and sort of borrow a little bit of energy from the gravity of Mars to fling it faster. It'll circle around then and come back to Earth. And actually in December of 2026, we'll make a close pass of Earth and borrow some of Earth's momentum to give it another boost. And that'll finally shoot it up to Jupiter, where it arrives in April of 2030. So we're sort of 5.5 years is the thing. And then the mission begins.
So 5.5 years to get out there. Once the Clipper's there, will it be able to send information back? Like how quickly? How quickly will that transmit?
It'll radio
happen?
information, data, photos, all of those things. While it's passing by Europa, all of the instruments will be going full tilt, gathering as much data as it can, because these are sort of fleeting opportunities. And then once it's backed away, the spacecraft will transmit the data to Earth. So there'll be these batches of information. And we're sort of used to how that works with other kinds of planetary missions, where you kind of get these big chunks of data, and then people start to pour through them and figure out what they're saying. And I think the pictures will be fantastic.
All right. So while this mission isn't designed to specifically look for life, Ivan, let's just say that it ends up being the first step in maybe a series of missions that eventually discover some form of aquatic life there on the moon. I think the big question in all of this then is, will this change the way we think about the nature of life in the universe? I know that's a big question, but I wonder about that.
The first question will be, is this really life or not? And there will be various, people will come up with various explanations for what it could be, because there'll be this caution about, is there no other explanation than it's alive? But if all of these things are ruled out, and let's say a follow-up mission is able to go or even grab a sample, or who knows, send a submersible down through a crack and take a look and see what's down there. If we do find life on one of these icy moons, of course, it's extremely exciting, because it means we're not the only place in the solar system where life has emerged. But it automatically makes it more likely that there's life elsewhere in the universe. We live on a planet that's a certain distance from its star, and we have this sort of idea about what's perfect for life. A rocky planet with oceans that, is far enough away from its star where it's not too hot and not too cold, and liquid water can exist on the surface.
This is the Goldilocks
zone,
right?
Goldilocks planet, right? It's sometimes called the habitable zone. But this is an example of an object that's well outside of the habitable zone. However, because of the specific conditions where you have these tidal interactions with the other moons, which can create some internal heating, and you have water and other necessary ingredients present, you have a miniature little habitable zone there that's outside of this Goldilocks idea. And of course, you think of all the other solar systems, and there are many giant planets orbiting other stars, and surely they have many moons, and some of those moons probably have ice and may be heated in this way. So it could even be that this kind of environment, an icy moon around a giant planet, is a more common environment for life than the kind of thing that we experience. So it says a lot about our universe.
We'll be back in a moment. So, Ivan, we've just talked about the Europa Clipper mission. Now, let's just kind of run through a bunch of different space stories that have made news lately, because there have been a few things happening that I want to get into.
Lots going on in space.
Yeah, and we don't talk about this enough. So, I want to ask you about something that I've read. We have a new mini moon now. I didn't even know this was possible, but what's going on here, Ivan? How do we actually have a second moon?
We do have a second moon, sort of, for a very limited time. It's a limited time offer. It started in late September. It'll be with us until late November and then gone again. And this actually happens from time to time. What this is an asteroid. It was discovered this year, a very small asteroid. So we're talking 10 meters across. This is like the size of a house, basically. This object is typically orbiting the sun, but it's come close to Earth in a way that's causing it to loop around Earth before it kind of gets on its way again and resumes orbiting the sun. So it's possible for asteroids to be trapped in this way. All the planets have their own little gravity well. And it's possible for objects to orbit around Earth. And it's also possible for objects to kind of be on the cusp of, if they're in the right place at the right time, they can be orbiting the sun, then they can sort of transfer. It's almost when you step onto a moving sidewalk in an airport or something, like if you just time it right, suddenly you're going that way, or then you step off and you're doing so. So it could be orbiting the sun, then it can be orbiting Earth. This one won't even make a complete orbit of Earth before it's exiting off again and heading out. There are others that could be trapped for years in this way.
So this is, I guess, in a way, kind of like a little mini vacation for this asteroid. Like it's leaving the asteroid belt for a bit, come in and hang out with us, and it's going back to the asteroid belt.
It's going to go back, yeah. And it's not a main belt asteroid. This is actually one of these objects that orbits in an area similar to Earth. So, in fact, some of these are objects that we worry about because it means that in future they might pose a threat if they were actually hit the Earth. This is not going to happen in this case. But there are other objects that we think about, especially if they're larger, where they could do significant damage if they were to land.
And you mentioned it's pretty small. So can we see it from Earth? Can we see it if we look up into the sky?
This would be very difficult to see. It's not an object that small. This is not a naked eye object by any means, or even a backyard telescope object.
Interesting. Okay, next space topic, Ivan. Let's talk about the International Space Station, because I think a few people will remember news from a few months ago that two astronauts, Butch Wilmore and Sonny Williams, they're up there a little longer than planned because of safety concerns regarding their ride home. That was a few months ago. That was June when they got stuck up there. Have we gotten any updates from them since?
Yeah, they've become satellites of Earth in a way, for longer than the other one will be. First of all, let's make it clear, these are experienced astronauts. They had both been in space before and done spacewalks and so on. They were sort of the inaugural crew for the Boeing Starliner, which is sort of a rival to the SpaceX Dragon capsule, or, sort of another private sector effort to provide transportation to low Earth orbit. Anyway, but the bottom line was they delayed the return. Eventually, the Starliner capsule was brought back to Earth empty, without a crew, just because of the safety concern. It landed fine, so it came back in September, early in September. But Wilmore and Williams are still up there, and their ride has arrived. There's a Dragon capsule up there, but it's not scheduled to go back now until early in the new year. So they're going to be up there for a while, much longer. It'll be more like 8 months instead of 8 days. Wow. But it shows, there are always going to be these surprises with this move to more privatization of space. There are, all these different systems have to come online and prove themselves, and this is a tricky one.
Yeah. I also want to ask you, Ivan, about the James Webb Space Telescope. Of course, we've talked to you about this on the show before. This is the telescope that is looking deep into the universe. It was launched in 2021. Have we gotten back any interesting findings from this?
So much interesting stuff. We obviously could do a whole episode about this, and maybe in the future we should. I'll just mention one thing, because, as you say, one of the things that the James Webb Space Telescope is really great at is peering into the deep universe, farther than ever. And of course, as you look further back in space, you're also looking back in time, because it takes time for light to reach us. So, something that's 13 billion light years away, you're seeing it as it was 13 billion years ago, around the time when the universe was very young. So the hope is that if you could keep looking far enough back, you might see sort of the galaxies just beginning to assemble themselves and take shape, and kind of get a sense of what that first chapter of the early universe is like. Sometimes it's called the cosmic dawn. The first pictures started showing up in the summer of 2022, so it's been 2 years now. And those early pictures were packed with galaxies. I mean, the foreground was amazing. You'd look at a particular galaxy or a particular subject, but the background was astounding. It was just crowded with these remote, distant galaxies that were just kind of spilling out of the picture, it seemed. But the surprise was how many there were, and also how much more massive some of them seemed. If people have been following this, they might have read some stories like, did James Webb break the universe? Like, did it break cosmology? Is it finding things that theory says shouldn't exist?
So we would have expected to see smaller galaxies further back then?
Maybe smaller and maybe
Okay.
fewer. We sort of have a rough idea of what the universe started like. You had the Big Bang, and then, the Big Bang leads to kind of a universe that's full of hot gas, basically, and dark matter. So there's this stuff called dark matter, but there's also ordinary matter, which makes atoms. And in a fairly short amount of time, those atoms have to turn into galaxies. Some of these galaxies might have very large black holes in them. Not a surprise, because today, when we look around at our own galaxy or at other galaxies that are closer by, large galaxies, each galaxy is thought to have a supermassive black hole at its core. But the question is, when did that form? How fast does it grow? How does it relate to the galaxy as the galaxy is forming and growing? So it seems like maybe part of the answer is that these black holes form pretty quickly and get heavy fast. And even though they give off no light because they're black holes and their gravity is too strong to emit light, they would have lots and lots of hot gas around them, which would give off more light than you might otherwise expect, which would then make a galaxy look bigger than you think it is because you're using the brightness of the galaxy as a kind of proxy for its mass. The bottom line is that maybe the universe isn't broken, but it seems like galaxies are forming pretty fast, so some theories probably have to be adjusted, and black holes are probably, or it looks like black holes are a big part of the story, which is interesting.
Wow, so we're learning a lot of new stuff here. This is incredible.
Absolutely. I think the hard part is that the story is changing every few weeks as new material comes out, as new results are put out. It's a very dynamic time now, for our understanding of this.
Just before I let you go here, Ivan, I just want to ask you about one more thing. This is about a particular asteroid. It's called asteroid 20045. And it's also known as Semeniuk.
Yes, it's an asteroid. It's an asteroid I've come to know well.
Ivan, how did an asteroid come to have your name?
Of course, hundreds of thousands of asteroids have been found now. And you can nominate names. Some are named after individuals, some are named after other things. And so the Royal Astronomical Society of Canada nominated a few journalists and science communicators in Canada. And a bunch of us last year were informed that asteroids were named after us. So it's a bit weird having an asteroid up there. I don't think of it as my asteroid, but I'm happy to have some association with it. It's 4 kilometers across, we think.
Oh, it's a big asteroid,
I
guess it's all relative.
Yeah, it's all relative. It's currently in the evening sky. You can't see it because it's too small and remote, but it's moving right now between the constellations Aquarius and Pisces. And I have not yet seen it with my own eyes, but one day I will get a sufficiently large telescope and try to spot it.
Wow. Amazing. Ivan, this has been so interesting. Thank you for being here.
My pleasure, always.
Before we go, we have another bit of space poetry to share. This is part of a poem written by our producer, Michal Stein. And it's about those astronauts stuck on the International Space Station. Here's Michal reading a stanza from Two Astronauts.
The roses were in bloom when our ship set sail, but June spilled into July, and still we were doomed to float in our aluminum tomb.
That's it for today. I'm Menaka Raman-Wilms. This episode was edited by Kevin Sexton. Our producers are Madeline White, Michal Stein, and Ali Graham. David Crosby edits the show. Adrian Chung is our senior producer, and Matt Frainer is our managing editor. Thanks so much for listening, and I'll talk to you tomorrow.